Hey everybody, what you're going to see right now is a clip of another video, a full lesson video on simplifying rational expressions. This clip that you're going to see in the next bit is just dealing with some of the quirkier situations, some things to consider when you've had a little bit of extra practice and simplifying rational expressions go pretty smoothly. I hope it helps. Good luck. So let's take a look at J and K. Now, I'm going to throw a couple little quirks at you within J and K. So I'd like you to just listen to my instructions carefully and we'll kind of see if we can match up. On question J, all I want you to do is factor the first line. So if we recognize, hey, I've got 3 terms on top, 2 terms on the bottom, there is not a common factor in all 5 terms, then we're looking to factor both expressions. So what I'd like you to do, factor the top and bottom. Okay, pause it now. Okay, we're back. So the top is a simple trinomial. That should have been automatic. X minus 3 times x minus 4. On the bottom, you have a common factor of 2. We factor out that 2, and we are left with a 4 minus x. Okay, now I want you to see, can you reduce that fraction? And I'm hoping that as you look at that, our first instinct might be no. It absolutely should be no, as long as we recognize that x minus 4 and 4 minus x are not the same thing. Clearly, those are different. X minus 4 versus 4 minus x. Like if I was just to sub in an x value of like 3, well, my first expression equals -1, my second expression equals 1. They're not the same thing. More importantly, though, you can see that they're not the same thing because the signs are different on each term. In the first term, I have a positive x, second term a negative x, first term a -4, second term a positive 4. So they're not the same thing. So we can't divide those out. So what do we end up doing then? Well, I'm just going to erase those crossouts because that would be a horrible action to take. So for me to just kind of fill that in a little bit again, we had our x minus 4 on top and a 4 minus x on the bottom. We may have the reaction that, nope, then we can't reduce. And I'm hoping that we can see that we can actually reduce this. It just requires us to use a little bit more of our factoring skill. If we acknowledge that that x minus 4 and 4 minus x are really close to being common factors, they just have the opposite signs, then I'm going to argue to you, well, how can you change the sign of something? Notice, and I'm just going to highlight, that our decision to factor out a 2 here could have been a different decision. Like, we could have factored out a -2 if we wanted to. And look what happens if I factor out a -2. Well, now, -2 times -4 gets me back to positive 8, and -2 times positive x gets me back to -2x. And now notice we just cured our problem. What I have is an x minus a 4, so a positive x and a -4, and I have the same factor now. So know that you have that as an option if the signs become a problem. Just make sure that we factored that correctly. Notice both of my signs had to be opposite. Okay, now I can go through and I can divide out that common factor. And that leaves me with an x minus 3 over a -2. Okay, there's 2 problems here. One of which we don't have our restriction. So we should notice then that x cannot equal 4. If it did, we would have our divide by 0. But also I want you to notice that that final form that we have in red is not a good form. And the problem specifically comes from that minus on the bottom. I want us to understand that having a negative on the bottom doesn't make sense. If we recall what division means, so if I ask you to take like 6 and divide it by 2, really what I'm asking you to do is to take 6 things, that's my quantity, and break them up into this number of groups. Like really that's what that division means. So if I ask you to take 6 things and divide them up into 2 groups, you're going to tell me that you have 3 things in each group, and I say, congratulations, we know what division means. I just want to draw to your attention, what does that mean for that? Yes, you can calculate that and tell me that it's -3, but what does it mean for division? I want you to take 6 things and divide them up into -2 groups. Like I might even say to you, just divide it up negative once. Give me -1 group. And hopefully we can see that a quantity of negative groups causes a problem. So how can we manipulate our expression? Well, we can take that negative and we can move it up onto the top of our fraction. We've reviewed this before. A negative divided by a positive is the same as a positive divided by a negative. So I'm going to take that negative and I just need to make sure that I apply it to all parts of my numerator. Well, now what I can do is I can expand my top. That's going to give me a -x plus 3 over 2, and we're so close to a good form. We would actually prefer that expression to be written in this form. And maybe you can see why. I'm going to count out on top the number of operations that I had to write. 1, 2. I had to put the negative and then the positive. In my final expression, notice, I only had to put one sign, one operation. And so that's why 3 minus x over 2 would be deemed to be more simplified. Okay, I'm just going to tack and maybe get rid of my highlighter. I'm going to tack on that restriction again, and there's our final expression. Nice. Okay, so there is a little bit for us to consider. Maybe we have to factor out something to manipulate the expression in order to reduce. And then we had a little bit of a form issue there. Okay, I'm going to put a little squiggly line down, and I think we should be good to go through K. I don't think we're going to hit a snag in K until the very end. So I would like you to start that one off and go all the way down to a final simplified expression. Okay, pause it now. Okay, we're back. So I'm hoping that the actual reducing, the algebra, was pretty automatic. I have a simple trinomial on top, 2 numbers to multiply to give 6 and add to give 5. They happen to have 2 variables. That's no problem. We're good at factoring that. On the denominator, I have a difference of squares, so that can factor into conjugates. I notice that I share a common factor of x plus 2y, so I can reduce that by dividing it out, and I come down to that point. So I'm going to argue that should have been really automatic by now. If that wasn't automatic, I'd be a little concerned. I think I'm missing something, and I really need to make sure that I'm asking some questions or getting a ton of practice or looking back over the lesson. Okay, where I want to talk about this problem is now how do we state restrictions? That you'll notice that, well, your restrictions now, okay, well, I have 2 variables on the bottom. So does that mean I need restrictions for x and y? And we might start to go, oh, this is just like question C, where we had to state restrictions on both. And I'm going to tell you, no, you don't. I'm going to write down some stuff that you are not going to do. You're going to do this in your head. But I'm going to look back to my first factored form to get my restrictions. So my first factor could equal 0. Or my second factor could equal 0. And both of these instances would give me something undefined. So what I have then is my two restrictions in gold. If x equals negative 2y or if x equals 2y, that is undefined. So I need to tack on that x cannot equal plus or minus 2y. Now, can you just look back into my boxed in factors and can you see that we could have done that mentally? Okay, here becomes the next part then. Some people are going to go, okay, but now I need to solve that for y. So now I'm going to take this equation and instead go like 2y equals negative x and y equals negative 1/2 x. And I'm going to say, don't waste your time. You already have that here. Couldn't you just divide out your 2? And then some people go, oh, so I need to write that my y can't. Don't. That what I've circled in green is sufficient. It's enough. That what you actually have in this instance is a dependent restriction. In all of our previous problems, you were stating a restricted value that was a constant, right? Look back at your last problem. X can't equal 4. All of our restrictions were constants. So you're restricting a value that it could be. What you have in that green circle is we're restricting a relationship. It's a dependent restriction. My restriction on x depends on y and y on x. So what that actually says, now that I can erase all this stuff down below, is that my x value cannot be, and I'm going to ignore the plus or minus for right now. I'm going to write it so it's, but in an idea, I'm just going to ignore it. My x value cannot be double my y. So for instance, if x was 2 and y was 1, there's a case where my x is double my y. Notice that if I went and I subbed that back into my factor, x is 2, y is 1, then I get 2 minus 2. There's my 0. But it doesn't just have to be x is 2, y is 1. The blue says x can't be double y. So let's say that x was 10. Then my y value can't be 5. It could be anything else, but it can't be 5. And you'll notice that back at the top again. If I replace my x with 10 and I replace my y with 5, I get 10 minus 10. So we may view it as, oh, now I have 2 variables. Oh, that means my restrictions are going to be more difficult. It's like, no, what you have circled in green is perfect. It's just that it's a dependent relationship on that restriction. X and y can't compare in a certain way. That's what we need to restrict. Okay, we've covered a ton of mechanics today. I want to have one more quick discussion, and then I think we're good for some practice.